All right, let's take a glance at the quiz. Remember, we've already went over it in class, okay? You've seen it once. I think it would be beneficial and helpful if you're able to see it again. Also, I'll take pictures and post the pictures, and you can just print out the pictures if you would like, okay? Now, the first one is matching the actual scientist name or the name of the experiment with the questions below. So who discovered the nucleus? The nucleus was discovered by Rutherford. What experiment was used to discover the electron? That was by the cathode ray experiment. The cathode ray experiment. Who discovered the electron? The electron was discovered by Thomson. The experiment that was used to discover the proton. The proton was discovered by using the gold foil experiment. Who included energy levels into their model? That was Bohr. Who discovered the actual neutron now? That was Chadwick. Okay, let's keep going. The question here says, which of the following is the correct order in which the three subatomic particles are discovered? First to last. So when they were discovering the atom, or they figured out, okay, things are made up of atoms. When you're going to discover anything, you're going to discover the outside layer before you can discover the inside layer. So the outside layer was discovered first, so not the protons, not the neutrons, not the protons. The only correct answer was C. Okay? The electrons, the protons, and the neutrons. Why were the neutrons last? Because they actually have no charge. What particle or particles are found in the outside of the nucleus? Electrons only. Now here are Dalton's atomic theories. 1, 2, 3, 4. This is what Dalton thought. Okay, he wrote down what his thoughts were. Now, which part of Dalton's theory did Thomson disprove? Now, Thomson discovered the electron. So he had to prove something that had to do with the electron. So he discovered a subatomic particle, which was the electron. And Thomson disproved Dalton's theory of all elements are made up of tiny indivisible particles called atoms. Okay? Absolutely incorrect. Yeah, they're made up of atoms, but not indivisibly particle, not a solid marble. Okay? It has subatomic particles. And those particles make up the atom. Now, using Dalton's theory over here again, the question says, look at isotope 12, carbon 12 and carbon 14. They are isotopes. Isotopes disprove which of Dalton's theory? So again, his theory was disproved because of isotopes, particularly part 2. Atoms of the same element are identical. They're actually not identical, because then we discovered and found out isotopes. So that was disproved. Next page. The next page here in the quiz is going to go over some actual calculations. So let's look at that. Okay. First one here, calculate the molar mass of SN parentheses NO3 close parentheses 2. You must include the correct SI unit. Now, calculate the molar mass of this. So, molars, MOL, mass is in grams, okay? And for those of us who, just to remember, the molar mass SI unit is a gram per mole, okay? Now, to find the molar mass, you had to find out whatever atom or molecule that they're asking you, and you're going to count every single atom in that substance. So let's go ahead and write it down. We have SN, we have an N for nitrogen, and an O. And we are having to use our periodic table. Looking at this compound, there's only one SN. Because there's no number behind the little n, then that means that there is a number 1 that's like invisible. Okay? The nitrogen, there is a number 1 behind it. It's invisible, but this 2 is going to be distributed inside of the parentheses here and here to the O as well. So 2 times 1 is 2. 2 times 3 is 6. Now let's go to our periodic table. What is the mass of 10SN? 118.71. Nitrogen is 14.007. And then oxygen, remember we just rounded that one to 16. So 1 times 118.71 comes out to 118.71. 14.007 times 2 comes out to 28.02. And then 16 times 6 is 96. Now we're going to get all 3 numbers and we're going to add them together because molar mass says to add every single atom together. In this case, 242.73 grams per mole. And then you include what we're talking about. We're talking about SN parentheses NO3 close parentheses 2. That is the correct SI unit. Alrighty, let's try this again. Let's see what else we've got over here. So we're going to talk about a different one. Determine the mass. If you're looking for mass, then my question mark is I'm looking for grams of 0.155 moles of sulfur. That is what's given to me. I'm gonna have to use dimensional analysis. So what do I do with the dimensional analysis? I write down what they gave me. 0.155 moles of sulfur. And for me to do dimensional analysis, I need to cancel out. So if moles of sulfur is up here, then moles of sulfur has to go down here. That way they can cancel each other out. Again, you have the formula chart that you can use, or you probably have your little mole map also that you can use. Either one. I like the mole map. Some people do not like it. That's fine if you don't like the mole map. But let me grab my mole map so I can go through that while we're talking over this. I'm starting off at moles, and where am I going to? I'm going to grams. That means I'm starting off at moles right here, and I'm moving one step to grams. If I move this step, I must use the molar mass from the periodic table. Okay? So I need to use the periodic table when I move this direction. Alrighty? So let's go ahead, and we know that 1 mole is equivalent to, well, what is sulfur on the periodic table? I'm going to come over here. I'm going to write this down. Sulfur. Go to the periodic table. I found it to be 32.07 for the mass number. So 1 mole of sulfur is equal to 32.07 grams of sulfur. Now my moles of sulfur can cancel out. I'm left over with grams, which is what I'm looking for, the mass. I can come over here. I'm going to say equals, multiply the top, and the bottom number is just 1, so whatever the number is at the top is the answer. I ended up with 4.97 grams of sulfur. That is the correct SI unit and the correct way to answer that. Alrighty, let's keep going. Next question that's on the quiz. Determine the number of moles So I'm going to go ahead and circle this, question mark moles. If there is 1.33 times 10 to the 24th formula units, what's the shortcut or abbreviation for formula units? FUN, fun, of iron oxide. Okay, well, what do I do when I do dimensional analysis? Step 1 is to write down what they gave me. 1.33 times 10 to the 24th FUN of iron Fe oxide, O2. Now, I already know before I go any further that if I have FUN up here, I have to put FUN over here. So I'm going to put FUN of iron oxide, so that way they can cancel out. Now I'm going to go back to my mole map. I have formula units and I want to go to moles. Here are formula unit and I want to go to moles. So I'm going to go one step this direction. And what am I going to use? I must use Avogadro's number. Okay, so let's go ahead and do that one then. So in this case, 6.02 times 10 to the 23rd FUNs is equal to 1 mole of iron oxide. Now in this case, I can go ahead and cancel out the FUNs. I'm left with moles, which is what I'm looking for. I'm done and I can stop right there. Get the top number divided by the bottom number. In this case, I got an answer of 2.21 moles of iron oxide, FeO2. Now I'm done and that's the correct answer. One more. Okay. It says here, how many molecules, so this is what I'm looking for, question mark MCs, are molecules of carbon dioxide are in 50 grams of CO2, carbon dioxide. Step 1, you write down what they gave you, 50 grams of CO2. The next step is if I have grams of CO2, I have to put it down here. So grams of CO2. Now let's go ahead and go to our molar map. I'm starting off with grams and I want to go to molecules. I'm starting off with grams and I want to go to molecules. For me to do that, I have to take a jump here and then a jump again. I can't just go straight to it. So that means that I must have the periodic table to find the molar mass. And then after that, I'm going to use Avogadro's number. So let's do that. Let's do our step 1. Let's get our compound, break it apart to carbons and oxygens. How many carbons do I have? 1. How many oxygens do I have? There's a little 2 behind it, so I have 2. What on the periodic table is the mass of carbon? 12.011. And oxygen we memorized at 16.00. So 12.011 times 1 is 12.011. 16 times 2 comes out to 32. Remember, we're going to add them together for molar mass. And when we add them together, I ended up with 44.01. So down here, 44.01 grams of CO2 is equal to 1 mole of CO2. Now I'm going to cancel out my grams. I'm at moles. Am I done? No, I want to get to molecules. So let's go ahead and do another line and another step. If I have moles over here, I have to have moles of CO2 down here. I'm at the moles level, mole step, and I'm going to go to molecules. So for me to do that, I must utilize Avogadro's number. Well, I already know that moles has to go down here. So 1 mole of CO2 is equal, right, because this is equal to what's on the top, Avogadro's number, which is 6.02 times 10 to the 23rd molecules, MC, of CO2. Let's go ahead and multiply the top number, and then we have the bottom number. When I did that, I got 2.93 times 10 to the 12th over 44.01. And I am telling you, you need to use parentheses. Okay, let's go ahead and do this division. And I got 6.84 times 10 to the 23rd. Here's the SI unit, molecules of CO2. Okay, let's keep going. One more page. We just left a lot of space so that way we can do our work. They wanted you to answer, this was number 10, 11, 12, and 13. Alrighty, now that it's on paper, maybe it's a little easier. If you need to, then draw this and write this on a piece of paper. Neon is what I'm using, so let me grab my periodic table. Okay, what is the atomic number of neon? Neon's right here. Its atomic number is 10. 10 so happens to be number 10. The mass, they told me, was 21. Okay, well, how much protons are in neon? If the atomic number is 10, then it has 10 protons. If it has 10 protons, it has 10 electrons. Why? Because it's considered to be electrically neutral. Unless something's over here that has a negative, like if there was a negative over here, a positive, until then, we're considered to be electrically neutral. What is the number of neutrons? To find the neutron number, that's the number, or that's where we get the mass number, and we subtract it from the atomic number. Okay, so in this case, we're going to get 21, take away 10, which equals 11. So the answer to number 11 so happens to be 11. Well, let's write this symbol since we're still here. We're here together, even though this wasn't a test question. The mass number is 21. The atomic number is 10, and that's the correct way to do it. The next one is gold, Ag. I'm sorry, silver. Gold is Au. Ag, silver. So what is this element? This element is Ag. I'm just going to come over here and put neon, and I'm going to put silver. What's the atomic number for Ag? Ag is number 47. So the number of protons are 47. What is the number of electrons? Again, there's nothing about a little negative or positive on this side. So in that case, we are considered to be electrically neutral. Then there are 47 electrons. Well, what about the mass number? This is my mass number of 107. What do I get? The mass number of 107 is going to go over here. 107. But what about the neutron number? To find the neutron number, I get the mass number, which is 107, take away the atomic number, which is 47, right? And then I'm going to end up with the neutron number of, what do I got? 47. Why did I go blank for a moment? 47 to 57, 67, 50, 60, 70, 80, 90, 107, which is 60. I just went blank for a moment. Now, this is not correct, 107 Ag. At the bottom, 47 should go down there. Okay, now it's correct. We filled in the chart. You will have a chart on the test. Please make sure that you see that this 10 or this 11 or this 12 and 13, they're just asking for what's the number in that spot only, okay? Here we go. The Lewis dot structure for calcium and beryllium, or barium. Barium. Well, calcium is right here and barium is over here. Now, I can go ahead and do the Lewis dot structure. Remember, the Bohr model gives me all of the electrons. The Lewis dot structure, let's go ahead and jot down a little bit of information, is only the valence electrons. That's it. Which equals the group number. And I know you've been taught this already, but we haven't talked about it necessarily here in class. That's in Unit 6 notes. but I know you've talked about this already. This is considered to be group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. And on group 2, that's how many valence electrons it has. Everyone who's in group 2. Everyone who's in group 1 has only one valence electron. Well, carbon is in group 2 and barium is in group 2, so they both have only 2 electrons. That's it for the valence shell. I'm not saying total. Total, they have more than that. So Ca has 1, 2, and Ba has 1, 2. So here's this one, and here's this one. They are different? No, they're the same. False. They're not different. They're the same. Okay? Let's go to the next question. Last 2 questions are multiple choice. This one here says circle all that are true. Ba has 2 dots in the Lewis dot structure. Well, that's true. Ba has 2 valence electrons, which is true again. Ba has 2 electrons in the Bohr model. No, because the Bohr model uses all electrons. Ba has 2 protons in the nucleus. No, it has, well, if Ba is number 56, then it has 56 protons. So A and B are the only 2 that are both correct. An atom is considered to be electrically neutral. True. Yes, it does. Because, why? Because the number of electrons and protons equal each other. Unless it tells you differently, it is considered to be an electrically neutral atom. Okay, so we went over every question. I'm going to take pictures. I'm going to post that so that way you can look at that, and hopefully that's helpful.